All right, welcome to the review for the Unit 2 test on functions. So the first page of the review is this chart, which we've already taken a quiz on. We've done a few times. So the easiest part is the names. So for number 1, that is a rational function. It's a W. And it is, the graph of the rational function is the hyperbola. Now, for the table of values, what I do is I just pick the first table of values and plug in. And this says 1, and if I plug in 0, I get 1. And as we know, when I throw stuff, we can't divide by 0, so that one's out. That one can't be right. That one can't be, oops, sorry, I really shouldn't be crossing these out. But can't do that one, can't do that one, can't do that one, can't do that one. Oh, 0 undefined. 0 undefined. So it has to be one of those two with the red marks. So which one is it? Well, if I plug in 1 into this function, I get 0. But 1 over 1 is 1, so it's not that one. It has to be this one. And this one makes sense because if you plug in 4, you get 1/4. So that one's out, and the answer is G. Now we have to find the domain. Sorry, let's leave that crossed out. So now we have to find the domain. I'm going to use that one. I'm going to use that one. So the domain is tricky. It's the key thing is that in a rational function you can't put in 0. And so this here is the domain, BB. Because this is all values except for 0. So I can cross that one out now too. So the second function, well, this is a quadratic function whose graph looks like a parabola. So for the quadratic function, let's start this. If I plug in 0 squared, I do not get 1. If I plug in 0 squared, I get 0. I plug in 1, I get 1. But if I plug in 4, I should get 16. So not that one. This one, 0, 0, 1, 1, 4, 4. That one doesn't work. Negative 1 squared is not 1, so that one doesn't work. 0 I can square, so that one doesn't work. Doesn't work. 0.5 squared is 0, no. Oh, but look at this last one. 0 squared is 0, 1 squared is 1, and 4 squared is 16. So this is I. And now we need the domain and range. And if we look at this function here, I'm going to erase where I crossed it out, is what we will see is that it goes everywhere left, right, but it does not go below 0 in the up, down. So that means the domain is all real numbers, but the range is all positive numbers. So that has the restricted domain. That has a weird range. This has a weird range. This has a restricted domain. Ah, here we go, GG. The key here is this bracket, and it tells us that 0 is included. Now I'm not going to cross that out because if you read down here it says one of the domain and range choices is used twice. So I got to be careful. For f of x equals x, that's just a linear function. And the key to a linear function is that the graph is a straight line. And if f of x equals x, it's whatever I put in is what I get out. So right here, C. And then the domain is, in this function I can put anything in and I can get anything out. So the domain is all real numbers and the range is all real numbers, which is right here. So this is I. All right, number 4 is the exponential function, whose graph is that one. So now for the function here, let's try it at the first one. If I plug in 0, I get 1. Well, 2 to the 0 power is 1. That looks pretty good. 2 to the first power is 2, and 2 to the fourth power is 16. There is our winner. And then we have to look at, once again, let's look at the graph here. If we look at the graph, once again, it goes left to right and up, down. But the key thing about the exponential function is 0 is not included. So I need a domain of all real numbers, but GG can't be used because this includes 0. Instead, I'm going to have to use HH because 0 is not included. For number 5, I need one where I take the square roots. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. Hey, look at that. Once again, it's a square root function. And the graph is that half sideways parabola. So that's Q and Y. And then this is our first one with a restricted, or our second problem with the restricted domain, is I can plug in 0, but I can't plug in any negative numbers. But I can plug in 0, and so I get CC. For number 6, this is the absolute value function. The graph looks like a V. The key for this is that negative numbers will turn into positive numbers, which is what we see right here. And so this is D. And if we look again at that V, 0 is included. We can put in anything we want for the domain, but the range is 0 and positive. So there's GG again. And then we've now used GG twice, so I'll go ahead and cross it out. This is the greatest integer function, which is AA. It has that weird step graph. We need something that when we put in a fraction, we get the next greatest integer, so that's here at H. And it has a weird range, is that the range only outputs integers. All right, number 8 is the constant function. The graph is just a horizontal line. The output is, like I said, it's a joke. No matter what we put in, we get out 2. And so our range, the only thing that comes out of that function is 2. And for our last problem, the logarithmic function, well, at this point it's fairly easy, but I'll go through it. It is a logarithmic function. The graph is that reflection along y equals x of the exponential curve. The table of values is similar, as you can try these in your calculator, but you would see that those would work. And the domain is we can't put in 0, and that's the key thing. That's what differentiates it from some other things. And so that's FF. So you need to know that chart backwards and forwards. You need to know what goes with what and why. So make a table for each function. Be sure to include the vertex. Graph the function. So I know right away that this is going to look something kind of like that from our previous experiences. So let's plug in the values of 0, 1, 2, 3, and 4. So 0 squared, I'm sorry, I'm incorrect. It would be up here because it's plus 2 with the transformation. But that's just a rough sketch. We want an exact graph. So if I plug in 0, I get 2. If I plug in 1, I get 3. I'm going to go 4, actually. We're just going to do a few points. 0, 1, 4. And that'll be good enough. This will give me 4. And so I get 0, 2, 1, 3, 1, 3, Sorry, I'm a little close to the board. 1, 3, and 4, 4. And there's my graph. The domain is, and I will accept either set builder notation, x such that x is greater than or equal to 0, or interval notation, 0 to infinity. But the range is all values of y such that y is greater than or equal to 2. Remember, there's no values that come out less than 2. So for this one, all right, so this is an absolute value function. But it's going to be shifted. It's going to be shifted down. It's going to be shifted to the left 2 and up 1. So now I'm going to end up with a graph that looks kind of like that. But we want exact values, and we want it to include the vertex. So let's go -4, -3, -2, -1, 0. So if I plug in the points, and remember you can get a table of values from your graphing calculator. I get these y values, and so then I would plot them. -4, -1, -3, 0, -2, 1, -1, 0, and 0, -1. And right there we can see our V shape. So what is the domain? Well, it goes both directions to infinity. There's no restrictions on the numbers I can put in, so that's just either, set builder notation is x such that x is a member of the real numbers, or in interval notation, -infinity to infinity. The range is a little bit trickier. The range is all values of y such that y is less than or equal to 1. Remember, when we're talking about the domain and range, we want to map back to the axes. There are no y values greater than 1. Or -infinity up to 1. All right. Good news. If you read this and you were completely perplexed by 5 and 6, don't worry about it. They're being excluded from the test. So we just need the values for which f of x is increasing and decreasing. So remember, put your finger on the graph and go left to right. And we're just going to go, whee! We're going down until the turning point. And then we go up, and then we're going down again after the turning point. So these are the places in red I just did is the decreasing. So how would I describe those? So we look at the x values. So the first one is -infinity to -2, and the second piece is 2 to infinity, and we want both those sets together, so we would do the union. So that's the decreasing. The increasing is this piece from here to here. So we would do that interval as -2 to 2. And those are the values of x that we plug in x. The function is increasing. So circle the letter of the function with the same range of f of x equals x squared minus 4. So if we look at the graph of f of x equals x squared minus 4, we're going to get a parabola with its lowest point being at -4. So what we want to do is look at all of these functions and say, hey, which one of these is going to have roughly the same range? And probably the easiest way to do that is to look at the graphs. So the graph of A is going to look like this, but this asymptote it approaches is y equals -5. So that goes down below -4, so that does not have the same range. If we were to graph B, what we would see is that this is a parabola but shifted to the right to x equals 4, but it doesn't get all the way down to negative 4. So that one's out as well. For C, we would get a V shape, but the point of that V shape is at negative 4. So that one will have the same range. Now, this is where it gets tricky. D is in a shape you have not, is a equation you have not seen before, but if you were to put it into your calculator and look at the graph, what you would see is a parabola whose vertex was at negative 1. Whose vertex was at, hold on, pause, my smartboard just crashed. Whose vertex is at negative 1, negative 4. So it shifted to the left one, but it's also shifted down 4. So it does in fact have the same range. And this last function, if we were to graph it, is a half sideways parabola, but it's going to start once again at negative 4. So all three of those functions have the same range as the problem here. On the SOL, this would be a hot read, and you have to click and highlight all three of those in order to get the problem correct. All right, so this is the to see if we really understand how functions transformations works. So in number 8, minus 1 outside the function means shift all the points down 1. This is a plus 3, it's inside the function, so it's going to be a left-right, and stuff inside the function goes backwards of what you would think. So plus 3 actually shifts back 1, 2, 3. And we get a graph that looks like that. All right, negative inside the function means to flip it vertically, horizontally. So we're going to flip it horizontally along the y-axis. So this point stays, but this point now comes, sorry, my smartboard's off. Give me 1 second to recalibrate. So we're going to reflect along the y-axis. This point doesn't move. This point comes over to here. This point comes over to here. This point comes over, well, to there. And so we end up with a graph that is a reflection horizontally. For the this one is the vertical reflection, so points that were under now become above. All right, used for the following functions. Find f of g of 4. So for this one, I'm going to start off with finding g of 4, which is 3 times 4 minus 6, or 6. So g of 4 equals 6. So g of 4 equals 6. So what this problem is really asking for, if g of 4 equals 6, what it's really asking for is f of 6. So let's take that and slide it. Which is going to be 6 squared plus 4 times 6. So that's what we'd want to do if we wanted to evaluate a single function. But what if we decide that we actually want to do the entire function. So remember, work outside in. So if we want to create a whole new function, it's 3 times what we're going to sub in minus 6. And what we're going to sub in is the whole other equation. And so you'll end up with 3x squared plus 12x minus 6. And for the last one, remember what this means. This means find the inverse. So the trick for finding the inverse is to rewrite it as y equals, and then switch the x and the y. So what we would do then is we would add 6 to both sides, and we get x plus 6 equals 3y. Then you would divide both sides by 3. And you'd end up with y equals 1/3 x plus 2. And so then we would simply write the inverse of g is 1/3 x plus 2. All right, so this one is give the equation the graph. So first of all, we have to realize what kind of graph it is. It's quadratic. And the parent function for the quadratic was that x was squared. But if it's not at the origin, it's been shifted to the left 2. So that means that the shift is going to be inside the function, which is the squared part. But remember, stuff, this has really been shifted -2, but stuff inside goes backwards. And so remember, whenever you do these, you should always check in your calculator to make sure that the graph looks like the one on the board. For this one, this is a square root function. We know that, but it's also been flipped. It's been flipped horizontally. So this is y equals the square root of -x. So this last one says sketch the inverse of the function. And the key to this is to remember that inverses are symmetric along the line y equals x. So this point that was here is now going to be here. And it's going to curve down like kind of like that. So what we would do is we'd start 3 over here. We know it's going to intersect somewhere along here, be a little bit here. It's going to kind of go like that. All right, well, hopefully that answers all your questions. If you have anything else, just bring it on into class, and I will see you. Good luck on the test.